Okay, calculus. Now we're looking at this next version here. We got some differential equations, or DEQs, some people try to call them. But we're looking at differential equations. How do we work through a differential equation? Well, we have a derivative, like this one here, dy dx equals 4x. And we want to figure out what y is. The goal is to solve for y. Get the original equation. That's what we want. So normally the problem is we got this plus c, this constant happening. But if you had some more information to substitute other known values, then you could solve for that mystery c. Let's go ahead and play this out. So let's just jump right into it. First one here. So I know that the derivative is 3x minus 1. What that tells me is that the original function, so f of x, is the antiderivative of this plus c. Well, if I were to take the antiderivative of 3x minus 1, what would that be? That's going to be 3x squared over 2 minus 1x, and then we got the plus c. So right here, I need to put this piece in there. Let's make that a little bit cleaner. Make it an official box. Here we go. This piece right here needs to go, oops, take that back. This needs to go up here. So we're going to have 3 halves x squared minus x plus c. Now that's helpful, but it's not complete because this c right here, this is a mystery. We don't know how to find that c. But we do know that for the second half, f of 2 equals 3. In other words, that means that 3 is what I would get if I plugged in 2 for x. So let's plug that in. That's going to be 3 times 2 minus 1. Whoops, pardon me. Nope, nope. 3 is going to be what I get if I have 3 halves. I'm going to plug in here using this equation. 3 halves times 2 squared minus 2 plus c. Now I can solve for the c because I plugged in my x and my y values. So let's simplify. 2 squared is really 4, divided by 2 is going to be 2. So that first term is just 6. So 6 minus 2 plus c equals 3. So this 6 minus 2 is really 4, so I'm going to subtract 4 from both sides. That'll give me negative 1 equals c. Now, again, remember, the actual thing that we needed to do was solve for y, or get y equals. We know that it's 3 halves x squared minus x based on the f of x that we got from using that antiderivative. But then we need to throw in the c. So this c that we found is negative 1. So the last term in it is minus 1. All right, let's look at this one. We're going to do this slightly different, just slightly different style, but same idea. And instead of f prime of x, we're going to say dy dx. Why? Just to kind of show you a different perspective on it. So dy dx equals x squared minus 2x plus 2. And then we're going to get back to this point where we say x equals 3 and y equals negative 1. So once I have this equation here, I can actually multiply both sides by that dx. That'll give me dy equals x squared minus 2x plus 2 times dx. So now I need to integrate both sides of this. And why would I need to do that? Well, because I'm trying to get to y equals. And the only way I can get from dy to y is by doing the antiderivative. So I take the antiderivative, and then we have this piece right here. So let's take the antiderivative of this. We have x squared is going to become x cubed over 3. We got minus 2x, so that's really minus 2x squared over 2, plus 2 times x to the first. And we got a plus c. Now, a lot of people, oh, I got this integral sign here, I don't need it. A lot of people say, well, wait, didn't the other side have a plus c too? Yeah, but the crazy thing is, what's a constant plus a constant? Well, a constant plus a constant is still a constant, so c plus c equals c. Because this is like c1 and c2 and c whatever. It doesn't really matter how many constants we have, we're grouping them all together by just doing the one constant here. Okay, so now that we're at this point, we're going to use the information we have from the beginning that x equals 3 and y equals -1. So I plug in those pieces, -1 for y, and 3 cubed over 3 here I got for the x. Now this 2 and this 2 in the second term, those simplify. So I just have -3 squared plus 2 times 3 plus c. Okay, so let's simplify even more. 3 cubed over 3, well that 3 3's on top and 1 on bottom, those will simplify. So this is really 3 squared. So I have 3 squared minus 3 squared plus 2 times 3 plus c. All of that equals -1. Well, 3 squared minus 3 squared, that's 0. So -1 equals 6 plus c, and we get -7 equals c. Now it's helpful, but what we want to keep in mind is this y equals portion. So we need to have y equals and fill in all the pieces. We started with x cubed over 3 minus x squared plus 2x, and then we got -7. Okay, now that we have all that, we have finished. We're finished. It's a differential equation. It said solve the differential equation. Find y equals some function of x. All right, done. Let's see the last ones here. We got a few more coming up. It says solve the differential equation. Okay, now what's going on here is a little bit different. Notice we got double prime. That means in order for us to get to y, we have to go from f double to f single, and then we can get to y. So if we know that f double prime of x equals 2, well, what's the antiderivative of 2 dx? That would just be 2x plus c. Okay, so f prime of x then is going to be 2x plus some constant. So now we can use this middle term here, because for f prime we know that when x equals 4, y equals 1, or f prime equals 1. So the output, let me write it this way, not y equals 1, that's not really accurate. F prime of x equals 1. So if I were to plug in 4, I would have 2 times 4 plus c. That's supposed to equal 1. Well, that's 8, so I'm going to subtract 8 from both sides, and I get c equals -7. Now, a lot of people say, all right, so I'm ready to do y equals. But not quite. You know, we still got to keep going, because so far all we've figured out is that f prime of x equals 2x, and then I got to add the c onto it, which in this case is -7. Well, now to get to my y function, that means I got to take this one more level. So I got to take the antiderivative of 2x plus -7, or 2x minus 7. Let's do that. 2x minus 7 dx. So the antiderivative of 2x is going to become x squared over 2 times the 2, and those 2's are going to cancel each other. Minus 7x. Now here's where it gets a little interesting. A lot of people, the instinct so far, we've only been doing this for a little bit, and our instinct says put a plus c there. Now that's cool and all that we know there's supposed to be a constant. But the confusing piece is, didn't we already find c? Well, because we're doing this more than once, we're going to be solving for more than one constant. So we shouldn't use c. Let's use a different number. How about h? I don't know. What do you guys want? How about d? D. So that's a d, capital D. So here's my function, y equals this. The problem is that I don't know what D is, but I could figure out what it is based on the information they gave us at the beginning. They told us that x equals -1 and y equals 2. So we can plug those in. That means that over here I would write a 2. On the other side I'd have -1 squared minus 7 times -1 plus d. Alright, this negative here with the 7 and -1, that becomes positive, so I have 1 plus 7 plus d equals 2. Let's keep going. We can subtract 8 from both sides and get rid of that 1 and 7. So we have -6 equals d. So wait, we got to go back to my y equals equation. Y equals, now it's going to be x squared minus 7x, but I got to use the d now, -6. Now it's done. Solved. D E Q. Differential equations solved. Check. Let's do another one. A lot like that first one. So we're going to start out with that first level, f double prime, and find its antiderivative. So what's the antiderivative of 2x dx? That would be 2 times x squared over 2 plus c, or really x squared over 2 plus c. Or not x squared over 2, just x squared. And we know that this equals f prime of x. So when we do the first antiderivative, we move from second derivative up to first derivative. Okay, so I know that if I were to plug in -5, that would equal 30. So I'm going to set that equal to this over here, but I'm going to solve for it. So I plug in -5, and I can solve for c. So this would be 25 plus c equals 30. You can probably do this in your head, but c equals 5. So in other words, f prime of x using c equals 5, and the original equation up here, x squared plus c. I shouldn't say original equation, the original first derivative that we found. It's going to be x squared plus 5. Okay, so let's see if we can go one more level. So we're at f prime. Now we got to do the antiderivative of x squared plus 5 with respect to x, of course. Let's move into, how about black? Okay, so the antiderivative of this is going to be x cubed over 3 plus 5x plus, now we've already used c, so let's say, how about w? We just got to figure out what that constant is, and that's our first original function. No derivatives, just our original function. We know that f of 2 equals -1, so that's my x and that's my y. Let's go ahead and plug those in. -1 equals 2 cubed over 3 plus 5 times 2 plus w. Okay, so there's a little bit of algebra in this one, but let's go ahead and work it out. We got -1 equals, this is going to be 8 over 3 plus 10 plus w. Okay, this is probably me, but this is how I would go about doing this. I'd move this 10, then get rid of that 3. So I'm going to move the 10 over here. That would give me -11 equals 8/3 plus w. And -11 is really -33. So what I need to do is subtract 8/3 from both sides, or -33 over 3, pardon me. If I subtract 8/3 from both sides, that would give me -41 over 3 equals w. That's helpful. But how? I need to go back to that original equation and say f of x equals x cubed over 3 plus 5x plus w, which in this case is -41 over 3. Excellent, excellent, excellent. Okay, we got one more to go. We're doing awesome here. This one is a very AP style question just because it's not really as hard as you would think, but it's very indirect. They give us all this information, but it doesn't feel like they give us that much. So let's see what we got. We got given that the graph of f of x passes through the point 1, 6. Okay, I'm going to stop here for 1 second. It says through the point 1, 6. That means they just gave me an x and y value for f of x. In other words, f of 1 equals 6. And the slope of his tangent line at some point x, f of x, is 2x plus 1. So okay, they're talking about the slope of a tangent line. The slope of a tangent line has to do with the first derivative. That's what I'm thinking. So in other words, they're telling me that the slopes, or the first derivative, is 2x plus 1. And now we're seeing this is really not a hard problem at all. But whoa. What are they asking us to do? They're asking us to find f of 6. Well, in order for me to do that, I need the original equation. Without the original equation, I can't work that out. Well, let's do that. Okay, so we got f prime of x equals 2x plus 1. We need to take the antiderivative of 2x plus 1. See what we get. So we're going to have 2x squared over 2 plus 1x plus c. That's our original equation. We know that f of 1 equals 6, so if I were to put this side equal to 6, I could plug in 1. This will be 1 squared plus 1 plus c. And subtract 2 from both sides, and I get 4 equals c. Alright, so that I can use to plug back into this equation, and I find out that f of x is in fact x squared plus x plus 4. There's the bell ringing. It's time to go to class. So f of 6, which is the question that they're actually asking us to find, is going to be 6 squared plus 6 plus 4, or 36 plus 6 plus 4, or 46. Check done dizzle. Alright, so final answer 46. So I'm going to stop this video here. I'm probably considering maybe, I'm kind of backsliding on what I was saying here, but I'm thinking about making videos for the midterm review, but go ahead and keep your eye out, see if it comes on up on YouTube. These should be up by, let's say, 3 o'clock. Thank you. Have a good day.